Um, some quick announcement first. Oh, wait a minute. What's happening here? Okay. The midterm will be next Tuesday. Okay, I believe it's May 21st in class. I will dedicate the Thursday lecture for the review. So I gave you 5 midterm, the sample midterm, for you to kind of seeing all the flavor of the question at the beginning of the quarter. However, in that specific session, I will first kind of eliminate all the questions that will not be asked in the midterm, which means that we haven't covered it, or that's not my focus. I'm going to eliminate question. So pretty much everything I cover today is not going to be on the midterm. So whatever content is going to be the material I already covered by last Thursday. Okay, so that's just tell you the range. So you will have some idea about what kind of the question I will be asking specifically. And then I will actually go through those questions, most of them, for you to actually see how do you actually tackle if similar questions are going to be asked next Tuesday. The other thing, which is that typically my midterm will emphasize more on any topic that related to homework. In this case, is homework 1, 2, and 3. So any concept. So I like to test you concept, but I like to bring you into the context of the homework. And within that homework, how do you apply that concept and things like that? So I mean, how to prepare that? I really think that if you have been followed the lecture, you have been working on the homework, you should be fine. You actually don't need to really need to go through the Thursday, the material I will cover on Thursday. However, Thursday is indeed important because sometimes under that 80 minutes, sometimes you feel nervous, you kind of miss some of the point. So it will be good to kind of tell you a little bit about strategy. How do you actually tackle those issues? Okay, so that's what I'm going to do on Thursday, and also we're going to have a midterm on next Tuesday. Okay, so I'm going to talk about 2 things today. So just let you know that for the midterms concerned, today's content, most of them are probably not going to be there, except if some of the content are related to homework assignment number 3, which is probably the first part. I'm going to talk about homework assignment number 3, the reference 3 in this case. So part 2, essentially. So what I'm going to do is I will first go through homework assignment number 3, part 2. And then the second part of the class, I will finish the topic of the virtual function, which is the last part about virtual function is about multiple inheritance, and it's about memory layout, which is, I would say today's lecture, everything, I look at today's content, I would say it's pretty advanced. Let me put it this way. You will see why. It's not so natural. It's not so as you expected. And sometimes you will see kind of tricks or kind of the system deliver the presence about a C++ programming language environment, which is none other programming language like a Python or Java programmer they need to worry about. Okay. All right. So first, I'm going to talk about how do you actually do what we call proxy object in the context of homework assignment number 3, which is the part 2. So CPB09, last week we went through a kind of a simpler example about how you can do proxy object. So the idea of a proxy object, let me just summarize very quickly, is that you can separate the concern about how you're going to interact with the object from the concern about where exactly is the object. So because the object could be somewhere in the network, and sometimes you need to track them, you need to worry about, you need to do a lot of things regarding the mobility and locality about this object. And that is, by the way, that is a big concern in object-oriented programming. Not only I want to interact with an object like a person, but also where exactly it was hosted in the server or in some network address is actually a concern if you don't have this kind of proxy object concept. Okay. So today I'm going to talk about, okay, so for homework assignment number 2 and 3, you have this concept with your traces, your identity, and then plus where you are at which time. So essentially that is a time location information, which is an array, which would basically help us to decide where we are. And maybe there is some application like a Google map need to use those information to actually perform some activity. For example, they want to see, oh, I want to see, well, how often you spend time in this particular location at UC Davis. So I kind of will be able to estimate how do I direct the social mobility traffics in UC Davis and such that I can schedule the class a little bit better and such that I kind of not have one area which is on campus is so concentrated. And so I can help. By the way, right after midterm, we're going to work on the final project. Okay, we're going to talk about that and I'll probably dedicate to that as well. Okay, so by the way, the code I'm going to cover today is already on the GitHub. Okay, this is a directory that has let me tell you some of the things that are new. First, that's very new is this thing called personal time GPS record. Let me actually, can I make it a little bit bigger? Let me see if I can get a little bit bigger. Okay. So you can see that I have this personal time GPS record.cpp and .h, which is the core data structure for part 2 of homework assignment number 3. And also, I create a new pair of homework 3 reference. So last time for part 1, I have this 2, homework assignment number 3 reference 2 server and homework assignment number 3 client.cpp. Those 2 are the pair of client server that's actually corresponding to the part 1 of homework assignment number 3. So for part 2, I now have homework assignment number 3 reference 3 client.cpp and homework assignment number 3 reference 3 server.cpp. So those 2 are corresponding to the part 2, as well as they're going to use the new class called personal time, the GPS record.cpp and .h. So those are handing in together and to implement the homework assignment number 3 part 2. So I do want to tell you that I gave a lot of information in the code. And I gave more information, by the way, I want to say I gave more information than you needed for complete your homework assignment number 3 part 2, by the way. The same case for part 1 as well. So you still need to do something. You still need to kind of understand what's there and then extract the part, which is really supporting to get the exact output for the homework assignment number 3. So but I do give you all the mechanism about how to use this feature, how to do certain things, and how do you build a template or the code for doing this remote procedure call. Pretty much all the code related to RPC is already given to you, just to let you know. There are some small things you need to change. You need to understand how to use the result, for example, extracted from the homework assignment number 3. Okay, sorry, from the RPC, remote procedure call. Okay, so by the way, the file is there and the make file has been updated. So pretty much if you are in the directory, if you download the whole thing, I do a make a clean, you see that we're building up. You see there is a lot of things get compiled. Give a time look. Oh, wait a minute, what happened? Oh, what happened? Can I get this? Oh, my make file must have a bug. Let me see, what's the bug? Why it didn't automatically generate the file? Let me check the make file. These things happen. I was cleaning, so I remove all the automatic generated code. 3 server. Yeah, this is fine. Why this is not? Yeah, it looks fine. There's 2 lines. Anybody see the? See any problem? Okay, there must be something else I need to look at. Yeah, I already have these things here. That's strange. Why it didn't work at the first time? Okay, anyway, I'll look at more carefully. So basically, the makefile has been updated, and it will generate this code. And again, when you want to run the program, you will run HW3 reference 3 server. I'll run the server, and then I will run the client. And the way to run the client is exactly like the previous. It's HW3 location.json, HW3 question.json. Okay, you can see that it basically get a lot of output, and you can see that it's actually interact with the server, which we will go into in depth. Okay, you can see that it's actually interacting a lot of information being printed from the server. So I kind of put in a lot of scenario. So at this moment, the output looks overwhelming. Okay, but we're going to go through that part by part, and you will see that it's not that complicated. It's to follow the same principle to do certain things. So as usual, by the way, it's good for you to see the contrast, the difference about how we're going to do proxy object versus the regular, the remote procedure call like CPP07 or CPP08. So let's take a look at the HW3ref3, which is, we look at that earlier, much earlier. Okay, if you look at this, when I make a call, the call looks like this. This is part of the code. It looks like. So I basically have this JSON RPC set up the locality about where the object is. And then I call this function my client.upload. Okay, so I'm actually calling a function remotely based on this handle of HTTP client called my client. Okay, so that's the typical remote procedure call. Okay, so let's try to look at the different. Let me keep these things here, and let me show you. Okay, let me actually, now we look at the proxy object. Let's take a look at this, how it looks like. Not this part. This part is similar, but I want to show you, not this part. This part is homework 2. I still keep the homework 2 there, but I want to actually show you where is the homework 3. Okay, here is. This one actually should be proxy object, not remote object. Sorry, I make the wrong annotation. Okay, so now let's look at this few lines of code. So I create a object called shadow object 1001. And the class I create is called shadow record. By the way, shadow record, the code has been given to you is actually being defined in the personal time GPS record.cppn.h. Okay, so I create a shadow record, shadow object, and then the only thing I really need to do is provide this 2 lines of information. The first line of information I provide, what's the host URL? And the second line of information I actually provide, what's the identity? Remember the difference between homework 2 and homework 3 is that now for each of the GPS traces, we associate that with an identity, which we simplify as a string, but you can imagine that this is in a real world system. It will be either your Gmail address or it will be your Facebook ID. Okay, so we're just using some kind of identity as a generalization. Okay, so when I call the upload, so instead of try to do that, whatever, you see that this is a remote function call, right? Remote function call upload. But over here, I'm actually just using this object and I directly call the function upload. So this upload is not remote procedure call. It's a member function. It's a member function of the class. I just call that. And then again, the question is also a member function. So basically, I take the object dot member function. By the way, you're wondering, well, what's the difference between these two? It's accomplished the same purpose. I'm kind of moving remote procedure call to a attribute, a member function. But let's actually take a look at this a little bit bigger. You can see that here, over here, I actually have a local version. So you see that I want to actually contrast this too. And I just realized I should have done this, so make it even clearer to you. I should have done this as well. This is called my local PTGR identity. So let's actually compare this 2 block of code. They look exactly the same, but they have the key difference. The first part under there is a local object. That means that I actually have a traces for this identity on the same computer where I actually run this program. So essentially, I actually kept a lot of local cache about this information, about myself or about somebody else, about my friends, so I can actually do some kind of computation and things like that. So in this case, the first one is a segment of code that's actually tried for me to manipulate a local object, nothing to do with RPC. In fact, when you actually execute this block of code, it has nothing to do with JSON RPC. Okay, it's just try to call something locally. But this piece of code is actually going to be remote. But look at the way we call it. The structure is identical. For example, this 2 line are the critical one. This 2 line, look at this 2 line. Let me do this. Let me actually extract only those 2 lines. This is the first part. And this is the next part. Okay, if you look at this 2 line compare, they're essentially identical, except the name of the variable, which I when I try to invoke as an object. Okay, so just we know because we actually see the context about the code, so we know the first one is a my local PTGR, which is an object of what we call personal time GPS record. That's PTGR. And the second one is a shadow object of a remote PTGR somewhere else. But the way we invoke, interact with the object is essentially identical because for the programmer, they don't need to worry about where is actually my local PTGR or where is shadow object 1001. Okay, so it gives us a separation about how we should interact with the object versus where they are. So this is kind of the nice thing about having a proxy object, okay? So the proxy object sometimes is not just a proxy for a remote object, but the proxy object could represent I'm actually really accessing a local real object. The real object is right here, okay? Okay, so let me, I think I forgot to answer this too. Let me just explain what the interface. So the first is just upload. So what is upload? Upload is you have a GPS traces that represent in JSON format that you upload that into the PTGR object. And then the second call is that, okay, I have a question, and the question in this case is represent as a time, as a JD time object. And so I actually insert that timestamp into that, and then the local object will try to find with that specific traces, what is the location, then it will return the GPS DD, which is the location to that question you just asked. Okay, so that's a high level. We haven't go into the detail about this PTGR. Okay, we'll go into that. Any question about what we have shown you so far? Perfectly clear or perfectly the other extreme? Okay, all right, fine. Let's look at the code. Okay, let's look at the file of personal .h. Okay, we look at the .h file first. So over here, I put both the real class, which is the personal time GPS record, but I also put the shadow record, which is a proxy in the same file. Okay, so that's why, because I need to deal with proxy, I have to put all the JSON RPC include file at the beginning. Okay, so those things, that's why they're there. So okay, first, this line I want to explain a little bit. So personal time GPS record is a single inheritance from the core. Okay, now you finally will ask, well, why do I bother to have a core? So the thing is that the design of the core was actually for remote object. Okay, so let's tell you what is the important thing about core. So core essentially is a placeholder for me to put all the information such as host URL. So this is essentially a core class, which if I means all the object I'm going to playing with, they inheriting from core, then they all have a place for host URL. So essentially this give me the information to generically represent each of the object, their critical information such as host URL. So it's I would say it's a design pattern that I start to use or other people start to use. In fact, I'm not the one who invented this. I was at IBM Research around 1991, I remember. That was probably the first large-scale C++ program I wrote. And my mentor, he insists we must have a core class, which is essentially every object we have will inheriting from here. And therefore, whatever things we want to apply generically to everything in our system, then we will place it in the core. Okay, so let me just tell you that that is just an experience that we have this core class. Okay, so now let's actually go back here. So now you see that I inherited from core. So which means that now this class called personal time GPS record has an attribute called URL, host URL that I can play with. Okay, so now let's actually take a look. So I have one attribute is called identity, and the other attribute is an array of this class we talk about is a time location pair. Okay, it's an array. That's exactly what we have been doing from the beginning of the class, is looking at where you are at which time. So that was the attribute we call it traces. So we have identity and traces. This match 100% to the JSON file for homework assignment number 3. Okay, and then we have what we call time GPS record, which is the constructor. And the next two function is, I'm not sure I actually talk about that, but for homework assignment number 3, ref2, I do have two functions, which is actually doing the sorting and the unique. So sorting and unique is trying to look at the vector of such as time location and look for anything that's actually identical. So for example, if you upload two time GPS location pair information and they're identical, so you should remove one of them, okay? Because it's duplicate, because one person should only need one location one time, and you don't need two records for the same person. It's the same time and the same location. That's duplicate. So essentially, those two functions, sort and unique, will help us to kind of clean up the array. The source code is there. If you want to use it, it's fine. You don't have to use it, depending on your scenario you want to implement. So we have those two functions. Now I actually build in as a member function. So you have a sort and a unique. Okay, so now we're looking at this two function probably you're already familiar with. Now this is those 5 are virtual function. Those 2 are dump to JSON, JSON to object, which I already talked about dump to JSON. I actually haven't started talking about JSON to object. It's the other direction, which we will be spending a lot of time trying to understand the design of JSON to object. I mean, it's not so much about C++ programming about JSON to object. It's about how do you apply the concept of exceptional handling. The only reason I want to leave this as the last one for the rest of the quarter after I finish inheritance, in my opinion, there's 2 topics that's most important. The first topic is template. Function template, class template, those topics are important for C++ programmer. And the other topic is exceptional handling. And exceptional handling, by the way, is very, very complicated. And a lot of people just did it wrong, okay? And for a variety of reasons. So we will go in depth into that. Okay, so we're going to talk about this later. So just remember we have a pair of functions we always have. One is dump to JSON, one is JSON to object. So we kind of have a two-way street that converting back and forth between the JSON world and the C++ world. By the way, if you can convert to the JSON world, you convert to, you can communicate with the Python world and Java world as well. Okay, so that is kind of a very useful intermediate representation. Okay, so having said that, now let's actually focus on the middle 3 lines of code. Okay, so the first 2 lines, you already see me doing that in the client. One is upload, one is question. That's actually exactly what we're doing for part 1. So we upload the record into this object. So essentially upload is getting the JSON and put these things into the traces. That's the upload, okay? And the second one is question. The question is just provide a time, and then you provide the GPS location from these traces. Okay, those 2 functions. Okay, So that's upload a question. Okay, the third one, I would say is an advanced topic. I will try to cover today. If you don't understand, I think it's no harm, okay? If you don't understand, but I feel is a good opportunity for you to understand. Can someone actually, based on what I said here, can you actually tell me, can you provide some guess what this is? What this line is declare? What kind of member function I'm declaring here? It's an operator overloading, right? Whenever you see an operator is operator overloading, the question is what operator I'm overloading here? This essentially bring the nightmare of both ecs36a and ecs36b, to be honest, okay? I'm overloading a pointer. So what is this? This is a pointer, right? The pointer is an operator. And I'm overloading the semantics about a pointer. Okay, if I know some of you really love pointer, and I admire you for your courageous behavior. That's good. Okay, that's good. All right. So just to let you know that in C++, we can make it even more exciting. You can actually overload the semantics of a pointer, and which in this case is actually useful because I want to overload a pointer in such that when I have a shadow object, that the pointer, because why? Let me give you a high level, why I have to overload a pointer. Because what is a remote object? A remote object is what? Is on a different memory space, right? Right? What is a remote object? It means the object, the memory footprint, is actually on the other, somebody else's computer. So the thing is that, but what's a pointer? A pointer is trying to pointing to some address, on the same address space, memory space. You can see that these two concepts already kind of clashing on each other, right? One is I want access to somebody else's address in C++. And on the other hand, the pointer concept is actually try to look at something in the same address space. So how do I actually resolve that? One is just forget it. Okay, it's hard. Okay, when you do JSON programming, you just worry about convert everything to JSON and then just use it as it is. Okay, and don't worry about this consolidate this two concept. Okay, which is really hard. That's why it's a lot of programmers choose not to touch this issue. Okay, but if you really want to try it, I can actually overload the semantic of pointer and such that when you bring in using the pointer operator, which is supposed to be the address of this particular memory space that I'm using. But using that overloading, you can actually pointing essentially equivalent pointing to a remote address. Okay, that's the trick you can play as a that's why I said this is at least more advanced than the intermediate C++ programmer. They will try to do that and make it nice. But I want to tell you that just like a C, if you learn C programming language, it's a really powerful. It's hard to learn. It's very powerful, but it's a dangerous language because you can do a lot of things with pointer, with address. And now you actually see C++ is the same thing. They inherit the same kind of challenge. Okay, you can, as a C++ programmer, with operator overloading, you can really overload the code, and looks really different. Looks simple, but in reality is very different. If you read the code, how many of you will actually doubt that this pointer semantics has been overloaded? As a C programmer, we don't want to think about that. Okay, but in C++ programmer, always think about, okay, is this operator has been overloaded? That's actually because you don't know who has done that. Okay, by the way, whoever did operator overloading must provide a lot of documentation, a lot of comments before and after that code. For example, if this operator is overloaded, I better say that right above that. So whoever read the code, they understand that this operator is actually an overloaded pointer semantics. Okay, all right, I will try focus on the first two functions. If I have time, I'm actually going to talk about this. The code, by the way, for this example, how to use it is already in the master directory. Okay, so let's look at upload. Okay, so so look at the whole class. I hope you remember that. Okay, at this moment, you only need to remember four things. Okay, the two things is I have two attributes. One is called identity, one called traces. And then the two functions that really matter is upload and question. Okay, those two. So we're going to see how this attribute and this two function got played in between the real object and the shadow object or proxy object in the CPP file. Okay, so this is the CPP file. By the way, I kind of do things very simple. You have to decide how you're going to put it. For example, a constructor, I just initialize identity to be not available. Okay. So let's take a look at upload first. So what is upload? Upload is essentially give me a JSON. I'm going to put it into my object. So I actually convert the JSON like HW3 underscore location .json. Let me actually show you what it is. This is the HW3 location.json. If you look at the information, which has identity as a first pair attribute, and then it has traces. Inside traces has a location, has an array of location and the time. Okay, if you look at this, let me actually make it more readable, more styled. So this is the trace, and this is an array. And then this is the first element of the array. And this is the second element of the array. And this is at the end of the array. Now I want to do this as well. This is at the end of the array. Okay. So if I kind of provide some breaks, by the way, JSON doesn't matter. You want to put multiple breaks, that's okay. This is still valid JSON syntax, but this is, I believe, in my opinion, much more readable. So it's give you a structure understanding about what is this JavaScript object notation. Is you have a first attribute is called identity. The second attribute is called traces, but the type of traces is an array. And this array has two elements, and each of the elements of the array has also two attributes. One is the location, one is time. Okay, this match 100% to the class we just designed called personal timed GPS record, right? This is perfectly because we have two things. One is called identity, one is called trace. So having went through this code up to this point, you should see that when I actually design the class, or you will be designing the class, you should actually think about, oh, I'm going to design the class exactly match with whatever data format I have on the JSON world. If you have a one-to-one match, it has a lot of advantage. I will probably give you a more example later when we talk about the project, but that is the idea. So when I look at the upload, okay, now let's look at the upload. Let's look at the upload. And what I did, oh, I want to go up a little bit. I cannot. Okay, fine. This is inside the upload. The inside the upload is really only one line of code. How do I do an upload? I just actually call this JSON to object, and I put that JSON object, which is actually equivalent to whatever on the top window. So essentially, I use the whole thing as a argument and passing to this function called JSUM2Object. And inside that function, it will check whether I have exactly the structure like I described on the top. If it fits, it will put that into the C++ attribute identity and traces. Okay, if it doesn't fit, let's just give you a heads up. If it doesn't fit, means that it missed traces or it missed a location or missed a time, it's going to raise an exception in the process. So this has always, if you see me have a try, that means it's an exceptional handling routine. I put it there. Don't worry about that right now, but later I will go into the much more detail into that. So what is upload? Upload is just bring in the data. So, okay, so let's actually move back to homework assignment number 3, part 1. So if you imagine that this particular piece of code is running on a server, this could be running on local, no problem, but this could be running on a server. So when you want to run on the server, where do you get that ARG-JV? It's actually going through remote procedure call. JSON RPC is going to pass from the client to the server, and the server will actually go in there to actually invoke this part of code. Okay, so that's the design. So if you think about this code, this class, upload is very short. Okay, it's really, really simple, just one line. Okay, right. If you know this, let's actually look at the next one is question. So look at the question part. I want to give you a design. I'm not claiming this design is accurate, but it works for this case because I won't want you to work out every case already for you. But let's actually look at this code. You should be somewhat still remember this. So this is a question. So the question is take one argument, which is the JV time, meaning that I'm questioning this particular entity, this particular identity, where you are at this particular JV time, which is I call it ARG underscore JVT. Okay, let's look at how do I use that information. So I assume I already have a traces. This is the traces is an array. It's a vector C++ standard array. So it has an attribute called size, means that the number of element in the array. So I would say have a loop like this and basically go through iterate through every single element from the first one until the last element. And look at what I did. What I did is I just say this traces I, because this traces is an array. And then dot to the time, because each of the element in the traces is what we call time to location. Has two attributes. One is time, one is their location. So I use the time, try to do the time diff. This, I hope you still remember, this is from your homework assignment number 2, right? That you use whatever the time I intend to compare minus this one. So you can see that if I actually have the time diff is greater than 0, and then I basically change the location. So I set the original location, the default, I call it default GPS, probably a bad name. I'm sorry about that. I set it to be 0, 0, 0, 0. And the thing is that whenever I realize I got a positive value, assuming the traces being sorted according to the time. That's why we need to have a sorting routine. And then I basically, if the time difference is greater than 0, means that is positive, then essentially I change the default GPS is equal to this particular time's associated location. And at the end of the question, I just return that whatever GPS. After I go through that array, I found the largest timestamp, and then what is location? Well, sorry, the largest timestamp before the question time, and what's the location? I will actually send it out. Looks like this. Okay, so that is how we handle. By the way, the logic is exactly the same with homework 2 and homework 3 part 1, but now I kind of separate them into a member function. But this is the real object called person time GPS record. Okay. Now we're going to see what the shadow looks like. Okay. So I want to see person. I want to see where's the shadow. The shadow is actually defined right below. Okay, so I actually have a class called shadow record, and it's inheriting from the first class called person time GPS location. Okay, so this is a subclass. So essentially I have a 3-class hierarchy core, and then to PDGR, and then from PDGR, I actually go to the shadow record. Okay, and inside the shadow record, and I don't have any attribute, by the way, because I inherit from PDGR. But I do have this 5 virtual function, upload, question, and operator overloading for the pointer, and dump to JSON and JSON to object. Okay, so I'm going to focus on this 2, which is what is the proxy version about upload and the question. Okay, how do I actually do that? So I put both class, both PDGR and the shadow record in the same file. Okay, just let you know. So you can see, I just want to tell you that what the JSON to object looks like. You see, everything is about exception. Everywhere is EI pointer. When you see EI pointer, is exception pointer. So there's a lot of exceptional handling. It's more than the real code. It's just checking whether you have this and you have that. But we'll go through that a bit later. Okay, here is starting with the shadow record. I have a constructor. So now let's look at the upload. You see, it's not that complicated. It's essentially moving the part that related to JSON RPC into the member function upload. Okay, so let's take a look at that. You should be familiar with the structure, but let's actually go over here. So the first part is really just set up the HTTP client. So instead of putting in the main function or somewhere which programmer got exposed to, but over here we kind of hide it within, this is called encapsulation. We kind of hide the detail about handling the location inside a class called shadow record. So only one person needs to design the shadow record, and the rest just use it and never worry about the locality. That's called a separation of the concern. So the only information I need to do with the HTTP client is the host URL, because host URL will give me the information about which IP address or which server I need to access to. Okay. And now let's take a look at that. Once you set it up, it's very simple. I'm actually calling my client upload, whatever the ARG-JV. By the way, that ARG-JV is the same one I show you with HW3 underscore location.json. So essentially what we're doing is we are calling it with exactly the same argument. That's why the programmer cannot tell whether this is actually going through a remote or this is actually local. The programmer cannot tell, and the programmer doesn't need to worry about that because the argument is the same. And that's why regardless which version of the code you will call, whether you will call the shadow record or you will call the regular one, it depending on the virtual function, because the virtual function will know how this class was created and decide which function. That's called polymorphism. Okay, by the way, polymorphism is a very powerful concept that it hides a lot of detail when you do programming. Okay, so once you've done that, I just call my client to upload and get the result back. That's it. Okay, so the design is actually fairly simple. Okay, let's look at the question part. Typically, the code typically is very short. Okay, so the same structure that you have the shadow question looks like this. And then you have okay, so the parameter is a little bit different because the parameter go into this code is actually JV time. It's not JSON. So I have to do a little bit tweak on the JSON part. So I have to construct the question. The question, okay, let's actually take a look at the question. So this is the question. The question has two attributes. This is from HW3. Okay, the question has two p-value pair. The first one is identity. The second one is a particular timestamp. So the way to interpret this question is that, okay, I want to find out from somewhere, from this object called PTGR, and this PTGR might be local, this PTGR might be remote, I don't care. But I want to find out that you have to give me a particular PTGR. The identity will match the identity I provide. I want to find the PTGR for Felix Wu. Then you provide Felix Wu's PTGR identity. And then regarding Felix Wu, I would say at that particular time, I listed there as a time string, where is Felix Wu at that time? Okay, so that's the sense of the question. It's exactly the same question for your homework 2 and homework 3 part 1. So, okay, so what we need to do then is try to construct the JSON that's represent that particular JSON. So you can see that we kind of reverted back. Okay, previously we just used it for the design of the member function. I actually use as a JV time. And I will explain why I have to do that. But essentially what I did is I make the time with the ARGJV time dump to JSON. I converted to the JSON format with the time. And then the identity is basically my identity. And then I actually just call my client question with that JSON as an argument. So you can see that when I do upload, I have a 1 argument. When I do question, I also have a 1 argument, which is being encoded over there. Okay, so now I want to go back to say, well, why do I have to do this kind of conversion? So you see that when I look at the design of the system, I designed a question, the input argument is actually JV time, which is not a Java format. This is a C++ time class that we developed through the years of ecs36b. So I have 2 choices. Any programmer has multiple choice. So I could potentially design this question to be JSON. So, okay, whenever you get the JSON, you try to extract the time. It's perfectly doable. Or I can actually decide to use some primitive C++ class to do that. Either of this case will work. It might be tiny difference in terms of performance, but I think both of them works fine. But the only thing for shadow class we have to make sure is whatever the type of the argument we decide to put it here, it must be identical or consistent with the real class. That's actually the shadow is proxy for. Okay, so let's go back. I mean, this is important for you to understand why we want to have a proxy, because we want to make this shadow, when you interact with the shadow, as if you interact with the real object or real class. So if you take a look at this, if you look at the question over here, no. So this is the real object's question. If you look at the function signature, they both have a question, and it's just they're different class. One is PTGR, one is a shadow record. They have exactly the same function signature in terms of data type. The return type should be identical, and the argument type and argument number should be identical. Okay, so then you designed it this way such that the programmer using this set of class, they don't need to worry about what's the locality, because they just treat it, even this remote as local. That's fine. Okay, that's a simple but it's quite powerful principle for engineer, programmer. When you actually want to develop a program that could live long, that could be really useful, you have to kind of make sure those simple principles you follow. Okay, so once we design this is actually quite simple. Once you've done this, you actually have a mechanism to forward the question to the server side. And so essentially, this suppose if the object is remote, it will get invoked at the other side of the PTGR's version of the question. And then you kind of complete the whole thing. So essentially for a remote object, you really call the function, member function question twice. You call it once in your local as a proxy, and then delegate through JSON RPC to the remote, and then you will call it another time for, and by the way, sometime you could call multiple times. Okay, by the way, I don't want to complicate your understanding about proxy, but a typical realistic proxy, they have a multiple proxy. So I could have a proxy from here to Google at Santa Clara. But it turned out the proxy at Santa Clara is also a proxy for another server in, say, Cambridge, UK. So in the sense that you could have this proxy multiple hop before you reach the real object. Okay, that's totally doable. Is by the way, you follow this example programming, you can actually do that. Okay. Okay, any question with this? So I'm going to, oh, I don't think I can go for anything else because I have to look at the client. Let's actually go back to the client. So let's actually refresh this client a little bit. Okay, by the way, if you look at the code, anything that's actually, no, not this one. Oh, that's why. I was looking at client 3, should be ref 3. Okay, so it's a reference 3 we're talking about. So by the way, before you see the now local object, before that, the code is essentially, I use it, I got it from hw3 reference 2. So it's a remote object. You will see that I'm not directly called the object, but only after I do this now local object is actually doing proxy. Okay, so you can see that the major thing is between this two things is one is the first one. Let me actually make a comment that this is the local object. So the real object here. Okay. And this one is the case, show you the real object is at the URL. Okay. So just tell you, but the thing is that as a programmer, you might not actually know whether let me actually give you an example. If I do this, if I declare a personal time GPS record star X, okay, it's a pointer. I call it XPTR. It's easier. Okay, so I do this, and then I can actually do this. I can just say XPTR is equal to M my local PTGR. Yeah, this is good. And then over here, I will just say call. Let me keep this. And over here, I will just say XPTR to the upload. Okay, I just do this. But over here, I'm doing the same thing. I will do X PDR is equal to shadow object 1001. By the way, I should put the M sign to represent this is address. And then over here, I can do, sorry, I should do it a little bit earlier. Do here, and then I have to remember a copy. And then I put X PTR to the upload. Okay, you see what I'm doing? I'm actually casting the and move the pointer, the address into a generic pointer XPTR, which is a pointer to the PTGR object. So if you look at this two lines, they're identical. The line I mark here, this line over here, and this line over here. The first line and this line, they look identical to the programmer. It's just a pointer and I'm calling a function. But you know, when you look at the context of the code, the first one is actually remote. The second, the first one is local, but the second one is remote. Okay, so that's the trick we try to play with proxy object. So such that the programmer doesn't need to worry about that. Okay, so that's the main trick about having this. Okay, any question? Okay, so now I want to kind of talk about the server side. So first, I want to show you. We do have to change a little bit. S2024 hw3 ref3. Okay, this is RPC specification. I specify it's a little bit different. I have an upload, which takes one argument, which is a JSON object. And then the second function is called question, which is also a JSON object, is one single argument. And then I introduce another function, remote function called dump to JSON, which is only take the identity of that object I tried referring to. So by the way, you don't really have to have this. The reason I have to have this is when I want to overload that pointer semantics. When I do this pointer semantics overloading dash greater than, when I want to change the pointer semantics, I have to introduce this extra function for me to do the transition. If I have a time, I will cover that. If I don't have a time, I will leave it later, but the code is there. You can actually take a look. Okay, so those are the function. So after we have the function, now let's take a look at the server side. Okay, the server side, not so surprised. You have a 3 virtual function, which is the upload, question, and dump to JSON. And take a look at the argument is consistent with what we specify. Is the first two upload and question are just a JSON. And the dump to JSON is the identity, okay? So those 3 functions. Let's actually take a look how it's implemented. So they all follow the same structure. The first one is upload. Okay, by the way, you've probably seen this before. The first part of the code is just for the server to keep a timestamp about when this request come in, okay? So this part, I should probably write it down so you don't confuse. The following part is just for logging of information for the server. Okay. And pretty much until here, I would say above is for logging. Okay, so now we can focus on the rest of the code, which is the, we're dealing with the PTGR. So again, we need to check. Whenever we receive a JSON, we always check whether it has identity, it has traces. Because this is from the remote, we cannot trust that they they actually is giving us a well formed JSON. So I have to check identity, I have to check the traces is indeed an array. Okay, here is something which is interesting, is that how do I actually keep all the PTGR object? Because I actually will, I mean, this is running on Facebook, I have a 2 billion user. So that means I have a 2 billion traces associated with 2 billion different identity, right? So I have to have a way to actually efficiently keep tracking about this. And the data structure I'm using is called map. You can see here, I have a structure called map. So map is similar to vector. So vector is an array of certain type, an array of time location, an array of GPS, array of Apple. Okay, so what is a map? Map is not an array, but it's a key value pair. So it has two arguments. You see that it's in between. By the way, every time you see a small than, a greater than, this is the template. Okay, the template has two types inside. The first type is a string, which is represent what is the key. And then the second part is the value. The value is a PTGR object. Okay, so this is a very useful template, which we will talk about that template at the end, a more systematic. I said two topic, template and exceptional handling. That's we haven't covered. But I want you to start to be familiar with this. It's not that hard to use. So essentially, I'm defining a map, which is, you will see that you can still access those as an array, but it has a second way of access is through the key, which is the key is the first one. So I'm actually putting the identity as the key. So whenever I have a map, I can actually go through the array to look at every single element and try to compare my identity. Or I just simply provide my identity itself and see that if you can actually find the entry that associated with that identity. Okay, so I create a map called HW3 PTGR map. Okay, inside here. I know if you never use map, this might be new for you to do this part. Okay. Okay, so now let's actually take a look at upload. After you check, this is the line I'm actually going to use the map. This is the way to use the map properly, is that I actually use a function called find. So this is the map called HW3 PTGR underscore map. And there's a member function called find. And find, you need to provide the identity, which is the ID string. I call it ID string. If you look at the ID string, is actually above here. How do I get ID string? I actually extract from this identity as a string. I got an ID string. So I use PTGR find this particular map. Okay, find that particular string. So this line is basically saying that whether, okay, I probably should comment on this one. This line is, the following line is doing this, is check whether the ID, which is represented by ID string, is available in, well, exist, I should say exist in HW3 PTGR map. Okay, I have to have a mechanism because you want to upload something. I want to know whether this user exists or not, right? If you want to upload something, which you want to ask a question, I need to see whether that user exists or not. Okay, so essentially we're saying that, okay, I have to do a check. So that particular line is actually doing the checking. And then once you check if this is not equal, which means that if it's not equal, means that it's there. If it's not equal, from the above line, it means that it exists. Okay, okay, exists. Oh, by the way, how do I actually access to that? If it exists, I want to access to that. You're actually using an argument called second. Okay, so you see this part? This part is fine. And then you say the second. Okay, so why is that? Why is a first and second? So map has two things. One is called first, one is called second. So just show you that it has two columns. You can think about it has two columns. So first and the second. So what's the first? The first is actually corresponding to the first type, which is the first in this case is actually giving you the key. And what's the second? The second is a second column. So the second is going to give you the record. So let me actually write it down. So first in this case represent the string. And the second is represent the PTGR object. Okay, this is about map. Okay, then you can actually get access to a particular record. Okay, later I will actually tell you an alternative way of doing this, but right now I'm only teaching you one way. But I'm going to do the document. I'm put the document here. So here, if you see that I can, I use find, but alternatively, what I can do, yeah, let me first not doing this. Alternatively, I can just do ID string. Okay, this two line, by the way, they're different, but in this case, they accomplish the same purpose. Okay, so this is, I'm using the find interface to do that. The first line, I'm just directly using like a JSON value kind of interface. I'm using the key as an index in the array, and then I'm supposed to retrieve the item. Okay. In fact, if you do this, if you use the first way, you probably don't need to use second. You just directly do like this. Okay, you can actually do this too, are similar, accomplish the same thing, but there is a critical difference. The critical difference it is, the second line, if you actually do the find, which is my preference, if this key doesn't exist, it won't give you anything. So if you do like this, if nothing, if the key doesn't exist, it won't create a new entry for that key. Okay, if you do it using find. But if you're using array, the key difference is that if it doesn't exist, it will create a new entry for that key automatically. So depending on what you want to do, right? I mean, if you think about your map and Felix Wu as a user never exists and doesn't have it, but if you use that first option, which is the bracket, it will automatically create an entry for Felix, but without any traces, obviously. But if you use the second way using find, then the record of Felix will not, still unavailable. So that's the choice. For this, I decide to use find because I want to make sure that if this user doesn't exist, I don't want to keep a record in my database. Okay. Okay, I'm going to just leave it there, and so you know the difference and why I choose this one. Okay, so this is update. Oh, I'm already done here. Okay, just give me 30 seconds. And then once you've done this, see here, I just basically, I'm doing update, right? See what I did was update. I actually just basically call JSON to object with that, whatever string. Let me see, I missed something here. Okay, I first, from the map, I extract this pointer called PDGR pointer, which is really pointing to that object in the map, that matching the identity I try to update. And once I done this, I will just call JSON to object. I actually merge that in. By the way, the JSON to object, it will merge all the new record. If you have an array of things, if you have an extra, it will just add it to that. So you actually accumulate the new record. So that's why over here, this is the same code with homework 3 part 1. You can see what I did is I just do a sorting and I do a kind of like a unique calculation. So I can actually get rid of that. Okay, so if you look at the question part down there, it's actually very similar. The way we're doing it's just a trick about how do you handle the map. The only thing that's important, it's not important. The difference in the homework 3 reference 3 server is the usage of the PDGR class and how to use the standard map. Okay, standard template map. Okay, I'm going to stop here. Thursday is important. Okay, give you a hint. I'm going to talk about so everything I will ask you next Tuesday will be covered on next Thursday. Okay, just let you know. All right.